All right, ladies and gentlemen, welcome to math class. Today I'm going to give you some tips and tricks for 7.3. So everything we've been doing in 7.1 and 7.2 has been leading to this. This combines the things we learned in 7.1, the probability, with the things we learned in 7.2, our counting techniques. So a couple things I want to go over here. This first problem is pretty easy. But it introduces a key concept which I want to talk about. So we have 15 letters here in a bag, and we want to figure out the probability of choosing a letter other than R. So we're not figuring out the probability of choosing an R, we're just trying to figure out the probability of something else. So if we have an event that is choosing an R, something that you will see, some notation, you'll see a little C in the corner there. The complement of the event is the opposite. So that C is called the complement. And the complement of the event is the opposite. So if the event is picking an R, the complement, which is what we're interested here, is in choosing a letter other than R. So one thing we know about complements, the probability of the complement happening. So in this case, the probability of picking a letter other than R is always 1 minus the probability of the event. So it seems kind of trivial, but this is a nice technique to use. So we could count all the ways, all the letters other than R here. So 1, 2, 3. This is going to take some time that I don't have. Rather, we can figure out all the ways to pick an R. How many R's are there? There is 1, 2, 3 R's. So the probability of picking an R is, there's 3 out of a total of 15. 3 R's out of the total. So that means to answer the question here, all we have to do is using this formula right here, is we have to take 1 minus our probability of picking an R, which is 3/15. And so here's where it helps to know your fractions. We need a common denominator. And we get 12 out of 15, which should make sense. If there's 3 R's out of a total of 15, that means there's 12 letters that are not an R. And then we can reduce that down. Both of those can be divided by 3. We would type in 4/5. So that's the first problem, and that's dealing with the complement. You will see several complement problems in this section. Another question that you'll see. In this case, we are forming a random committee of 3 people. And we have some administrators, some teachers, and some staff members. We want to know what's the probability that all 3 committee members are teachers. So, standard question for these counting problems, does order matter here? And if we're just randomly forming a committee of 3, we're not putting them in a ranking or an order or anything like that. So no, it does not matter how we pick them. We just want to pick 3 of them in any order. So the probability that all 3 members are teachers is going to equal the, so remember, denominator is going to be the total ways to pick 3 from, what's our total here? It is 37 plus 4 plus 6. So we have a total of 47 because we have 6 administrators. Let me put that down here. 6 admin, 37 teachers, 4 staff, which is 47 to pick from. And then we're looking at teachers specifically in this problem, so we're wanting to pick 3 from 37 teachers. So in our numerator, we're just picking 3 from, and we're just interested in all 3 of them being teachers here. So here's where our combinations come into play. Total ways to pick 3 from 47, where order does not matter. That is 47, a combination choosing 3. Ways to pick 3 from 37, that is a combination again, but our total is going to be 37, and we're choosing 3. So now we just need to work each of these 2 combinations and divide, and we have our answer. So off to the side here, combination of 37C3 is 37 factorial over 3 factorial. It's 3 factorial. And then we just have to simplify down. 36. I'm stopping at 34 and writing the factorial because 37 minus 3 is 34 factorial. Those cancel. I'm just left with 37 times 36 times 35 over 3 times 2 times 1. 37 times 36 times 35 gives me 46620 on top. 3 times 2 times 1 is 6. Divide those out. And remember, anytime you're working a combination formula, you should get a whole number. So that is our numerator. There is 7,770 ways to pick 3 teachers out of the total of 37. Now we can work the denominator. That is 47. This is a very similar looking problem here using our combination formula. (47 times 46 times 45 times 44 factorial). 3 factorial times 44 factorial. 44 factorials cancel, leaving 47 times 46 times 45 over 3 times 2 times 1. So there is 16,215 ways to choose 3 people out of the total of 47. So our numerator here, that we were choosing 3 just from the teachers, because that's what we're interested in. Then here, this is 3 out of the total of 47. So just to finish this off, we have to divide to get our probability. So that's going to be 7,770 divided by our 16,215. And then we can reduce that down, or we can divide it out and use the decimal version if we wanted to. So that's 0.491839. So there's about a 47.9% chance that all 3 will be teachers. So that's that problem. One final problem I want to look at here. Here we have 16 students, and we want to know what's the probability that our first 3 presenters are going to be Ben, Marcus, and then Benny, in that order. So, standard question, does order matter? And notice here it actually says we need Ben to be first, and then Marcus, and then Benny. So here, order does matter, which means we are using a permutation. So this here, so the probability of Ben, Marcus, and then Benny is going to equal, remember the denominator is always the total. Total ways to order 3 out of 16. And then our numerator is just number of ways to order Ben, Marcus, and Benny. So here we're using a permutation. So I'm going to figure out the denominator here. This is going to be a permutation, and we're choosing 3 out of 16 and putting them in order. So using our permutation formula, that is 16 factorial over 16 minus 3 factorial. So 16 times 15 times 14 times 13 factorial over 16 minus 3 is 13 factorial. They cancel them, the 13 factorials out, which means we just need to multiply 16 times 15 times 14 to get 3,360 ways to pick 3 presenters out of class of 16 and put them in order. So our denominator here is going to be 3,360. Now to figure out our numerator, we're wondering how many ways can we put Ben, Marcus, and Benny in that specific order? Well, there's only one way. Ben is always the first one. Marcus has to be second. And then Benny is the third. There's only one way to put them in order that way, and that's with Ben first, Marcus second, Benny third. So our answer here is just 1 over 3,360. So that's all I have for today. If you have any questions, please let me know.